All right, today we are going to continue with graphing. Today we're going to work on secant and cosecant graphs, but we're going to start off with a somewhat difficult bell work. Write the equation of a sine function and a cosine function that has the given graph below, and then we're going to use Desmos to help us here. Okay, so you're trying to do that. At first glance, it seems like not too bad, but if you jump on Desmos, then it might not be as great as you think. Okay, so here's our original graph. We are trying to match that graph, pretty similar to what we did on Friday, with either a sine or a cosine graph. Okay, the easier one would be sine. So let's start off with sine. Matthew, what do you need to do with this sine graph to get that thing to match up? What's something you need to do? Shifted it down one because the midline there is at -1, so we shifted down one. That helps me out. Good. Let me adjust a couple things. I hate when the colors are the same. Let's go, no, not purple, blue, green. Green it is. All right, there's our graph. Okay, so we moved it down one. Megan K, what else do I need to do? 1/2 in front of the sine. We got to change our amplitude. Cool, now we're between those red lines. Okay. Kate, what's something else I need to do? Flip it. Put a negative in front because I got it to match there. All right, cool. We're getting closer. Okay. The only thing left to do is change period length. What would you say the period length of the purple line is? Tell me now when I've gone one full period length. So I'm starting here. Tell me now when I've done a full one. Yeah, right there. Okay. At 4 pi over 3, I've done a full period length because I went down, middle, bottom, middle, top, middle, back again. Okay. So to figure that out, we want it to be 4 pi over 3. So if I want it, sorry. If I want it to be 4 pi over 3, remember what we do. We take 2 pi times something, and that should get me my period length. We're going to multiply by the reciprocal, whatever's in front of my x. So to get rid of the 2 pi, I can just divide both sides by 2 pi. So it's like times 1 over 2 pi over here. That's going to cancel. The pi's are going to cancel. 4 divided by 2. That's going to get me 2/3. Is 2/3 what's going to go in front of my x? No, what do I really need to put there? 3/2. 3/2, put that in front. Oh, cool. Now we match up because we multiply by the reciprocal there. Everybody go with the first one? Not too bad. Just kind of straightforward. We did that a lot on Friday. Now let's do the second one, a little bit tougher. Okay, we're trying to do a cosine x graph. So a lot of the basic stuff is going to be the same. Like I still want to go -1. Okay, I still want to do a -1/2. In fact, I still want to throw a 3/2 in front because the period length didn't change. I get to that point right there. They look pretty close, but they're not the same. What has happened to, what do I need to do to that blue graph to match the green graph? Horizontal shift. Which way do I want to shift it, left or right? Either way is perfectly a good answer. I could shift it either way. Which way do you want to shift it? Let's shift it right. So if we're shifting right, we would put minus. How much do I need to shift it to the right? Pi over 3. So minus pi over, womp womp. It didn't work. Pi over 2. It is pi over 2. That doesn't make any sense. It looks like pi over 3. Why would it be pi over 2? Good. The key there is the factoring out. Notice what happens here. If I put that x minus pi over 3 in parentheses, that is what I want. Okay? That might not make total sense, but it's about factoring it out. You are multiplying by that 3/2 as well. And so it's a little bit strange here with what we are doing. But if we don't put, you want to just put these other parentheses if you're writing it. But if that's not happening, what you really want to do is put pi over 2 right there. That's going to get me the same graph. Sorry, let me color code here. If I turn that on and off, you can see that those are the same graphs. Okay, they look different, but they're the same. It's because that 3/2 is factored out. Here's what we're learning. Okay, this is called a phase shift. We shift horizontally and we change the period length. That's going to make it the ugliest. That's what's going to happen right here. Okay, so just like we do with period length, if I have this equation right here, if I want to figure out my horizontal shift, we would start off with this horizontal shift right here, pi over 2. and then we would, oh my gosh, pi over 2, and then we would multiply by the reciprocal of whatever's in front of my x, and it gets me that pi over 3 to the right like I want it. Okay, it's the same thing. We are going to do that on Wednesday. So if that kind of blows your mind a little bit right now, that's fine. I'm not doing it today. I'm going to do it on Wednesday, but I just wanted you to see it. Okay, so this is worst case scenario. When you shift, horizontal shift, and you change the period length, it gets kind of funky. The key is, if you're writing an equation, throw it in parentheses. That way you don't mess it up. All right? All right, today we are talking about secant and cosecant graphs. Again, it's not a lot different than what we did last week. In fact, it should seem almost identical. When you get done, you're going to be like, oh, that's really easy. And it's not really easy. It's harder than what we did last week, but you're better at what we did last week already, so it won't seem too bad. Okay? So we want to graph some things here today. A reminder that sine and cosecant functions have a reciprocal relationship. Okay, just like secant and cosecant graph, or secant and cosine graphs have a reciprocal relationship. If I want to graph cosecant, the first thing I'm going to do is graph sine. Okay, if I want to graph cosecant, I'm first going to graph sine. So when I look at this graph right here, and it says cosecant, cool, I'm going to graph sine. That's what I have right here. Okay, this red line that's being graphed up here, that is just a sine graph. There's nothing fancy. I started at 0, middle, top, middle, bottom. I went 2 pi to make a period length. Everything I want. Okay, we'll fill in those blanks here in a second, but let's look at this. This is a reciprocal relationship. Okay, that means, think about what a reciprocal is. So I have this graph. I've got this point right here. What is the y value at that point right there? 1. What is the reciprocal of 1? 1. So when I graph cosecant, I'm going to make a point right there at 1. What is this point right here? -1. What's the reciprocal of -1? -1. So it's going to be a dot right there. It didn't change anything. What about this point right here? What would you say that y value is right there? A half. What's the reciprocal of a half? 2. So like right there, I'm going to be up here. Right there, I'm going to be up here. This is -1/2 and -1/2. So I'm down here. I'm down there. And I could get fancier. Like if I said right here, it'd be like 1/3. And if it's at 1/3, then I'd be up here at 3. And then 1/5 and 1/8. And I'd be at 5. And then at 8 and so on. And then let's get to this guy. What's the reciprocal of 0? It is undefined. Because remember what 0 is. 0 is 0 over 1. It's not 0 over 0. 0 over 0 is nothing. Okay, that's indeterminate form. But that is 0 means 0 over 1. So if I do the reciprocal of 0 over 1, what's that going to get me? That is undefined. So when I have a line on this graph right here at 0, I'm going to graph undefined. How do I graph something that is undefined? We make an asymptote line. We can't graph anything there. Okay, so if we can't graph anything, just like we did back a couple chapters ago when it's undefined, we graphed a vertical asymptote. So everywhere that I have 0, I'm going to make a vertical asymptote. And I say 0 right now because we haven't moved it at all, but it's really anywhere I cross the midline. Okay, anywhere I cross the midline, I'm going to draw a vertical asymptote. What shape? So we drew those vertical asymptotes. Remember what we do with vertical asymptotes? We get really close to them, but we never touch them. In between here, I got this point right here, and I'm going to these. What shape does it look like I'm making in between those asymptote lines? Parabola. And then down here, I'm using this point, and I'm going to make a downward parabola. And then up here, I would use this point and make an upward parabola. And then down here, I would use this point and make a downward parabola. And it would keep repeating until the end of time. Looking up at the board, talk with your neighbor for a second and explain why you think that is. How many period lengths of that cosecant graph did I draw? So looking at just the green line that I drew, how many period lengths did I graph? Talk to your neighbor and explain why. Show me with your fingers how many period lengths do you think I've graphed up there? Good. There are 2. There are 2. I've got an upward and a downward parabola, and then I repeat it down and then up. There's another one, okay, and so on. That is 2 period lengths. So the key to graphing cosecant, first thing you're going to do is graph sine, and then we are going to add the asymptotes and parabolas of the cosecant function. The asymptotes and the parabolas of the cosecant function. Same thing is true if we want to graph secant. Okay, when we see secant up here, when we see secant, we're thinking, oh yeah, that really means cosine. We're trying to graph cosine. So that's that blue line that's already graphed. I graphed your cosine. Once I've graphed cosine, I'm doing reciprocals. Okay, so anywhere I have a 0, that is a vertical asymptote. So vertical asymptote there and there. And so on. We could keep going all day long. Once I have my vertical asymptotes, then I'm going to make my parabolas. So I'm using the top points on each one. Okay, so I'm going to use this dot right here. And then which way is my parabola going to go? Up or down? Up, because it's going opposite of this. I'm literally taking this shape right here and I'm flipping it. It's going to become an upward parabola. I get really close to the asymptote lines I don't touch. Okay, same thing here. Using this point right here. Getting really close to the asymptote lines but not touching. Using this point right here. Getting really close to the asymptote lines but not touching. Okay, it does not have to be super accurate in terms of what the parabola looks like. As long as you use that point and then make an upward parabola or a downward parabola, I'm perfectly good with that. Questions with how to graph it? I've now taught you everything you need to know for this lesson in terms of what we're adding to it. But let's do it together. Here we go. We're going to graph this function. It is negative cosecant of 1/2 x minus 1. So the first thing I see is I say, oh, it's cosecant. What am I actually graphing if it's cosecant? I'm actually graphing sine. Okay, so we're going to set this thing up. Amplitude, period length, vertical shift, horizontal shift. Try and do that real quick with your neighbor. Get those 4 things filled out. All right. We are going through each thing. Amplitude here. Kara, what's my amplitude going to be? 1. What's that negative telling us? It's flipped. It's 1 and it's flipped. Good. And then we're doing period length. If we're doing period length here, I want to go, what's my period length going to be? 4 pi, because she's starting off with 2 pi, and then she's going to multiply by the reciprocal, so times 1/2. I'm just kidding. Reciprocal, I didn't do reciprocal. That's 4 pi. Vertical shift. Evan, what's my vertical shift going to be? 1. Yep. Going down 1 here. I've got this -1 tagged on the end, so I went down 1. Horizontal shift here. Megan, see, what's my horizontal shift going to be? There isn't one. What would it look like if there was going to be one? Where would it be? Good. Adding or subtracting something inside my x. Cool. We got all that. Now we're going to graph it. So I have a vertical shift of down 1, so I'm going to keep that in mind as I make my graph here. Well, let's do it. So we make our x-axis and our y-axis. Boom, there's 1. No, okay, I thought this was going to be easier, and it makes it way worse. All right, fine. We got those lines here. Let's just keep going here. Then 1, 2, 3, 4, 5. 2, 3, 4, 5. It doesn't matter. 1, 2. There's my hash marks. I'm going to label them. This guy right here is 4 pi. So this guy is 2 pi, 1 pi, and then 3 pi. I'm going to graph. So Lydia, what should I put next here on my graph? My midline, it's going to be down 1. So I made my graph completely wrong. So good job by me. This is going great. So down 1. Again, I wouldn't be smart when you make your boxes. You don't have to just make one a box here. And so that's going to be her midline right here in the middle. And then I'm doing amplitude. Where's my top line going to be, Matthew? At 0, what's my bottom line going to be? At -2, boom. There's that one right there. Okay, did all that, did my amplitude, my midline. Now I'm graphing cosecant, which means I'm really graphing sine. Where am I going to start to make a sine graph? Top, middle, or bottom? Middle. I'm putting a dot right there. And then from there, where am I going next? Down. I'm going to the bottom because it's flipped. So I'm down, and then middle, and then top, and then middle. And then I can make my graph. Because I'm doing everything dashed because none of this actually matters in terms of my graph. It matters, but it's not an actual part of it. It's going to help me graph it. Okay, it's like making the skeletal structure. Okay, you don't see my skeleton. It's there. It's important. But what really matters is the outside aspect of it in terms of my graph. That's the same thing here. Okay, so I made my graph. Once I've made my graph, Abby, what do I need to do now to change this sine graph into cosecant? I'm doing the reciprocals. And so the first thing I would do is my asymptote lines. Careful here. My asymptote lines are where I cross the midline. Okay, so where am I going to have a asymptote line here? Somebody tell me something. At 2 pi is going to be when I have them. Okay, right there, because I'm crossing the middle. I'm having another one at 0, and my next one would be at 4 pi. There's my graph. I'm graphing cosine. So I drew my asymptotes. Now I'm going to make my parabolas. So to make my parabolas, I'm using the top and bottom dots. So I'm using this dot right here. I'm using this dot right here. Using this dot right here, I'm making a parabola. Which way is it going to open? Down, and it's going to fit in between those two lines. Fit in between those two lines. Questions on how I drew my graph? Something we're going to add today. Okay. Let's now talk about domain and range. It didn't really matter before because so far, everyone we've done, the domain is all real numbers, and the range is just the top line and the bottom line. They were pretty easy. This is a little bit tougher. My domain here, to make the cosecant and secant line, it's just the orange grass. That's what we're doing. The domain is all real numbers. But x can't be what here? It can't be 2 pi. It can't be 4 pi or 6 pi or 8 pi or so on. How could I write that mathematically? It can't be any of those forever and ever and ever. 2n pi, where n is an integer. Okay. There's lots of different ways of doing this. I think this is probably the cleanest one here. Anytime we just talk about n, we are going to refer to it as an integer. You could make it different than that, but n is an integer here. Because now if I multiply it by 1, it'd be 2. If I multiply by 2, it'd be 4 pi, 4n pi, and so on, or 4 pi. Range, that's my y values. Know what I'm doing here. My range is -infinity until -2. Because my graph starts down here and is going to keep going to right there. And then from where else? 0 until positive infinity, because it's starting at 0 and then it's working its way up. Questions on that one? Let's do it again. So the next one, 2 secant x minus pi over 4 plus 2. We're going to start off, it's secant. So secant means I'm really graphing what here? I'm really graphing cosine. We're going to do amplitude, period length, vertical shift, horizontal shift. Talk with your neighbor, graph that thing. Let's do it. We've got amplitude of 2, vertical shift is up 2, my period length is 2 pi, and I went to the right pi over 4 because I got a minus pi over 4 in there. Okay, so we made my graph. I'm going to label this fourth hash mark as 2 pi. So if this guy is 2 pi, this is 1 pi, this is pi over 2, this is 3 pi over 2. We are graphing, so we did that first. Herman, what am I going to put next on here? Sure. Where's my middle line going to be? At 2. Good. So we're going to go to 2. And that's going to be our midline because that's our vertical shift. Cool. So I got that midline there. And then I'm doing top and bottom. Sam, where's my top line going to be? At 4 right here. That's my top line. Your bottom line? At 0. So top and then bottom is right there at 0. Okay, we've done that. Okay, then we're going to graph this thing. So Eli, where am I going to graph this? If I'm graphing secant, I'm really graphing cosine. So where am I going to start here to graph cosine? At the top. I normally would put a dot right here, but it's not going to go there. What do I need to do with that thing? Shift it over. How many am I going to shift it over? Pi over 4. So how many hash marks? A half of one. Because I'm not getting all the way to pi over 2. We could label it again if we wanted to. Hey, this is pi over 4. Okay, so there's the first one. So then my next dot is going to be in between these two. And then my next dot's going to be in between those two. And then my next dot's going to be in between those two. Just kidding. Went too high. And then my last dot's going to be in between that. There's my graph. So that one's at pi over 4. You don't have to label it all. I'm going to just label it for ease of use here later on. That was pi over 4, so this would be 3 pi over 4. This guy would be 5 pi over 4. This guy would be 7 pi over 4. You don't need to label it. I'm just doing it for you anyways. Cool. We made our cosine graph. And we just shifted it over. That's the ugliest it could ever be. I'm being mean to you on this one, but if you can do this one, you can do them all. Then I'm going to do asymptote lines. Ella, when am I going to have an asymptote line up here? Good. Where it crosses the middle. So anywhere it crosses the middle, that's where I'm going to have an asymptote line. And so she's going to look up here and say, all right, well, right there at 3 pi over 4, I'm going to have an asymptote line. And at 7 pi over 4, I'm going to have an asymptote line. Cool. We got that. Then we're going to graph parabolas. So we're going to use any point, like that point right there, I can make a parabola. That point right there, I can make my parabola. And that point right there, I could do that. Is that a full period length that I've graphed? Yeah, it's weird. You don't have to do that. You could just draw a regular parabola. I just always like doing that. I think it's cleaner at times just because it mimics the cosine graph that we have underneath it. This is a sad face. Oh, poor guy. Questions here on what we did? Let's get to the harder part here, which is domain and range. So let's talk about that real quick. Domain and then range. The range is easier. If we're doing range here, Max, what do you think on range? Negative infinity to 0. Yep, and we're including 0. And then where else? 4 to infinity. Wonderful. That's just his y value, so it's down here to here, and then from up there to on. The domain is going to be all real numbers. But x cannot be... Ugh. Aaron? 3/4 n pi. So if we did 3/4 n pi, like if we plugged in 1, that'd be good, because we don't want 3/4 pi. But what if I plugged in 2? Yeah. I mean, that, if n is 2, then it's 6 pi over 4. And I got a dot at 6 pi over 4 because that's 3 halves. But I don't want one at 7 pi. So we're close, but that's not quite it. Somebody got something else? So here?
3 pi over 4 plus n.
3 pi over 4 plus n. That? Okay, so if I add 1, then that's just going to add 1 to it. Does that work? All right, we got one. 3 pi over 4 plus n. That works because if I plugged in 0, it'd be 3 pi over 4. If I plugged in 1, then it'd be 7 pi over 4, and so on. That works perfectly well. You just got to figure it out. It's funky, okay? There's going to be some times when you do that and you don't like it very much, okay? My suggestion on my notes that I had written down was this. X cannot be n pi over 2 plus pi over 4. So basically, normally it was going to happen right here, but we need to shift it to the right pi over 4. And then it was going to happen right here, but I need to shift it right pi over 4. There's lots of different ways of doing it. You just kind of got to figure out which one makes sense to you and then go from there. Okay? Kind of funky, but we'll get better at that. That's not the most important part in this chapter. Questions there? Let's do one more. Try and graph number 3 with your neighbor and see what you can do. Go. Sorry, going back to this one. My brain was not working fully function there. It can't just be n. It's got to be n pi because we do want to add a full pi to that answer because I want 7 pi over 4. If I just added 1, although it seems like it's the right, it's not. You need to add pi with that as well. So it's plus n pi there because it's happening every pi. Let's look. Again, you might not have finished all the way, but we should be good here. Amplitude, it's 2. Does this negative matter? It cancels. I've got a negative here and a negative here. And if we know our secant rules, or our sine rules, sorry, that negative is going to pop in front, and that negative with the other negative are going to cancel each other out. Okay, we've flipped horizontally and vertically, and so there is no flip here. You don't have to write that out. I'm just writing it out here. This I can pull out in front, and it's going to make it positive. Therefore, it's not going to change my graph. Okay, period length. We're starting off with our base period length. It's 2 pi. Then I'm going to multiply by the reciprocal. So what's my real period length going to be? 2. So this guy's 2, 1, 1/2, 3/2. Vertical shift. There isn't one. Horizontal shift. Not one of those either. Nothing added inside the parentheses or added outside the parentheses either. Okay, so we're just going to make our graph. Our amplitude is 2. So there is my top line. Here's my bottom line. We're going to make our graph. It is a cosecant graph. So what am I actually graphing if it's cosecant? Sine. So I'm starting here in the middle, and then top, middle, bottom, middle. Connect the dots. There's my basic graph. That's not what I'm actually graphing. Once I've decided that, okay, now I'm going to draw my asymptote line. So I'm going to have an asymptote line right there. I'm going to have an asymptote line right there, an asymptote line right there. And I'm going to make parabolas that use these dots and then go upward. And then use this dot and go downward. There's my graph. Domain. All real numbers. X cannot be what here? X just can't be n. It can't be 0. It can't be 1. It can't be 2. That's where I have the asymptote lines. So just all real numbers except for n. My graph is everywhere else except for 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. Okay, it's weird. You'll get better at it as we go. Range. My range, my graph lives outside of this middle. It doesn't live in the middle. This is the no man's land. It uses every other y value because the graph is up here and it's down here. Oh, that's so ugly. There's so many colors that are making that ugly. But the range, okay, we're going from negative infinity until -2, and then from 2 to infinity. Questions on something we did today? Your homework for this evening is do the other 2. You got 2 more graphs on your paper. You got 5 minutes right now. You can probably get them close to both being done here in the next couple minutes. Go to work.